Okay, so welcome back. So just like we said, okay, this is going to be the public IP address. This is going to be my private IP address. Then this is going to be the default gateway. That's the router that assigns this private IP address to everybody on the network. That's why everybody on the network is going to have 192.168.181. Each person is going to be having a different last number. So this first three is called like the network address. Then, of course, this last particular one here is your host IP address. So we're trying to say something like if the network is, let's say, 192. Let me clear this. So if the network is, let's say, 192, right? 168, let's say 1.1. What's going to happen is that this is going to be the IP address of the access point. Everybody's going to pick 2, some people pick 3, some will pick 4, some will pick 5, up to 255, right? So that's the job of the default gateway. The default gateway is going to be doing all of those assignments, right? So those are some of the concepts we are going to be looking at as we look at addressing. Then we're also going to look at address classes. So what are the different address classes? You have class A, class B. Then we'll see what is the function of NAT. How does NAT do the translation between the private IP address and, of course, the public IP address? So let's look at that briefly. So this is a very straightforward and concise chapter. I've already summarized the things we're going to be looking at. So NAT does the translation between local or private IP address to what? To the public IP address. Because the point is, if we need to communicate with the outside world, we won't be communicating with the outside world with our router IP addresses. That's why you could go online and say, okay, I need a Netgear router IP and username and password, right? So you could even say default username and password for quite a lot of routers. So you see, most of them will commonly use 192.168.1.1 or 192.168.0.1. So this is the most common router. So it's from what this router IP address that it has that is now going to assign an IP address to you. So you're using Huawei, using Netgear, using quite a lot of manufacturers. Let's go to router login, right? So this is router login. Let's also go to default router login, right? So you're going to see the commonly used IP address for quite a lot of routers. Just a moment. Default router credentials. Okay. Okay, this is one. This is a link. This all router passwords is also a link. Don't forget, your router might be slightly different, but a lot of routers are going to use some of these default logins, right? So this is just a way for you to be able to access them. Of course, you are to now do configurations. You should not do changes and all of that to them. So this is default password. So the vendor, this 2-wire 360 3COM. This is Acton, ADP, AMI, what's it called? APC award. So see, it's a very long list. Airlink, Aeronet, Atlassian, BMC, Backlink, Boom, Brocade, Brother, CTX, Checkpoint, Cisco. So these are different types of routers. So most routers are going to come with this default. And these routers are also going to have their own IP address. So let's see something like, okay, you see, so this link has router password. So default router. So if let's say I'm using, let's say I'm using a Dell router, or let's say I'm using let me look for a common one. a common, let's say a highway router. So for Dell is going to, they'll tell you that, okay, you could see the address, the IP address behind the router or by the back of the router, or what was it called? In the manual of the router. So you have to put the IP address on the router, hit enter on your browser when you're connected to, hit enter, and you can try any of these username and password. So for these models, these are their default passwords. Same thing if you check for Huawei, right? So you see, this is the model numbers, their default name, username, and password. So these routers are going to have an IP address, and that IP address is what is going to be based on which it's going to assign local IP addresses to the different items you have on your network. So NAT is we translating that to the outside world, because the outside world will not be able to know that IP address. So what they're going to know is what the ISP has assigned to us. Okay, so this is how it happens. So you have this switch connected to this system, switch connected to this system, these two switches connected to this router. Now, the global IP address, which is the public IP address used by every other person, this switch is going to get everything, translate it into what we can use in communicating the outside world. So that is the summary or the use of NAT. So what are some of the advantages? So it helps us to conserve IP address. Imagine if we need to assign everybody IP address, but we don't need to do that now. Why? Because if we have a router here and it assigns multiple IP address to everybody, right? This guy, this guy, this guy, this guy, it assigns IP address to all of us. So everybody will just going to be using only one IP address, the IP address of the router as our internal IP address. Then the IP address that is assigned by the ISP to the router is going to be our public IP address. And when you go to your browser and say my public IP address, that's the IP address of the router. And that IP address can be investigated. You can get details about who owns the router, or who owns the ISP and all of that. You can put that on whois.com. It will tell you the details about that particular IP address. So that's one good advantage of NAT. So NAT helps us to conserve. So we see we're using just the IP address of the router, right? What's the disadvantage? Result in switching path delays, because you're going to switch from our local IP address to our external IP address. So remedies overlap, address overlap events. So this can cause lead to end-to-end IP traceability. So how do we trace who? So that's one of the things that IP version 6 solves. It solves the fact that each person can have the IP address, because we have billions and billions and billions and billions of IP addresses available. But for IP version 4, we just have only about 4 billion IP addresses available. And humans are more than 4 billion. Our gadgets and systems and cameras and cars and TVs and whatever are even more than 4 billion. Okay, so these are some of the advantages and disadvantages of the NAT system. Now, you also have types of NATs. You have the static one-to-one, you have the dynamic many-to-many, you have overloading. So let me explain them one after the other. So static NAT is going to help us do one-on-one mapping between the local, like the private, and the global address, right? So that's what it's going to help us do. Then you have dynamic NAT. So this gives us ability to map unregistered IP address to a registered IP address from out of the pool of registered IP address. So you don't, just like you have DHCP, you don't necessarily do a one-to-one, or like it's not bound to those items you have on the network. Then of course you have overloading. That's where path comes in. I think if you check my series on the channel, I think that's a video. The tool is part of Sys internals. It's Sys internals. Let me get the tools, just a second. Yes, TCP view. That's the name of the tool. So you can go to Sys internal suite, download this particular software. Is a zip file that have quite a bunch of, I think, up to 50 tools are created by a former employee of Microsoft. The software is still maintained. See, it was last updated in July. Now, if you go to, let me see the tools. I don't want to download this again. I think I already have it on my system. Okay, let me just say TCP view. That's the name of the tool. If you open it, by the time you load TCP view, once you just open it and try to start working on anything on your system, you're going to find out that you have ports. This is the ports, local ports. You see, this is the remote. This is the public IP address where these local ports are going to. So a port is just a line of communication. It's just like in your house, you have a port, you have a line. Just like in most countries, they said they said, okay, this is the local port, this is the C port, this is the port. So it's just a channel through which you can pass information. At home, you're going to have some wires that is going to send video cables to your TVs. You're going to have a cable that's going to send satellite cable from the dish and whatever you're using. You're going to have a cable that's going to send power from the transformer, from the mains, from the public system. You're going to have maybe a wire that's going to send, a pipe that's going to send, what's it called? Let's say water and all of that. So each of those ports, each of those lines of communication on PCs, they have numbers. And that's where one-to-many comes in. So port can help us, right? It allows you to permit thousands of users to connect to the internet using only one real global IP address, right? So if you check this diagram now, you're going to see that everybody, so this is my system. They have different ports. They are going to be connected to, are you seeing? If you watch now, you see this part of this application is using this particular port, but this is connecting to the same IP address or the same IP address in the same range in the same network. Several other persons around the network or around the internet are still going to be connecting to this particular stuff. How do you identify them? You're going to be using the port, you're going to be using the process ID, and you're going to be using the MAC address, you're going to be using the IP address of this particular system. So all of this is just a way for us to address, for us to be able to know items we have on our network. I think the student one asked a question that, what about the address systems and what about all of this stuff? So I would normally say you have different types of address on your system. So you should know them, right? You should know the IP address. You should know your, what's it called? You should know your MAC address, right? You should know your MAC address. You should know your IP address, which is a layer 3. You should know your loop back address, right? You should know your loop back address. You should know your, what other address do you have in your system? Then, of course, port helps us to like channel information across the network. Okay, so so this is just nomenclatures. If you do CCNA2, this will make more sense for you, and not necessarily within the scope of this course. For this course, you just need to understand what is NAT, what is PATS, the different classes of IP addresses, the advantage of NAT, and what are the limitations of NAT, and how has IP version 6 actually helped it. So your local, inside local is going to be your source host that you, before you translate. Your outside local is what your ISP assigned to your router. Your outside global is going to be your source host used for translation to get into the internet. Then your outside global is going to be the real IP address, like the public IP address that every other person can see. So I already explained how NAT works, right? How it does the translation. Like if you see this diagram for this software now, you're going to see that you have a protocol. Of course, you have a local address, you have a local port, you have a remote address, you also have a remote port. So this is just like local, remote, or remote global. So it's just a way for us to say, okay, anytime we're communicating to the outside world, where are we communicating to? Then if the outside world or that particular system there wants to know who is communicating, at least there are some identities. So your MAC address, your IP address, all of those things, we have knowledge of that so that we can know where that information is coming from. Okay, so the question is, why do we need IP version 6? So we have IP version 4, like I explained earlier on, and we have IP version 6. So why do we need IP version 6 and IP version 4? So IP version 6.4 is the earliest. So, but the point is that we need to know, or we have limits to how much IP address that we can have, right? So we need to communicate to more systems, and it's not sufficient because there's a maximum limit we can have. Let me head over to, let's say, ChatGPT. Just a second. Okay, so let me resume. So let me say differences between IP version 4 versus IP version 6. Let's have the answer in a tabular format, right? So one limitation you're going to find in IP version 4 is how many pieces that we can have, right? So we are limited. Look at this, just 4.3 billion addresses is possible. So that's to say we can assign IP address maximum of just only up to 4.3. Whereas for IP version 6, we have 340 on the zillion. So how many 340 on the zillion addresses do you have in 4.3? So how many of 340 do you have in 4.3 billion? So imagine you still have 479 octocillion times larger. So the number is quite, imagine, like 10 raised to the power 28. It's like saying 7.9. So 79. Then instead of 28, since you've approximated to the nearest 10, so you now have up to 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So this is how many times. So you have 4.3 billion. Then you have this time times 4.3 billion. So it's quite huge. So I know our kids wouldn't even need to bother about having to get more IP addresses. So that's the advantage of IP version 6, right? So you cannot have IP version 6 without security. So security is also a good thing we can have in IP version 6. Another important thing is that we have so widely used due to address shortage, right? Generally not needed due to large address space. Then another thing, if we are to implement this, if you have, let's say, a hosting server, you want to add an IP address to your server, normally you're going to be creating an A record, right? For a fully qualified domain name. But if you are doing IP version 6, you're going to be adding a quadruple A record, right? Another important thing you need to know that it is 32 bits. That's to say I have 192.168.1.1. So this is 8 bits, 8 bits, 8 bits, 8 bits. So how many bits is this address? And show workings, right? So we can see that this is 32 bits because this is an IP version 6 address, rather IP version 4 address. So we know IP address to be octet driven, right? So the question is, why are we even using these IP addresses. Normally, our computers are going to only understand ones and zeros, right? They're only going to understand ones and zeros. And if you translate this in binary, that is base 10 back to binary, you're going to get this. If you convert this in binary, you're going to get this. If you convert this, you're going to get this. Convert this, you're going to get this. So the maximum bits you can have for an IP version 6, it's each one is going to be 8 bits, 8 bits, 8 bits, 8 bits. Right? So this represents this. So you see that you're going to have a total of 32 bits if you check 888 bits. Now, let me copy my IP version 6 address. Let me copy this. Okay, how many bits is this? Right? So this is going to be 128 bits, right? So that's why we said the address length for IP version 4 is 32 bits, whereas the address length of IP version 6 is what? 128 bits. So the differences between an IP version 4 and IP version 6, you need to know it, right? Okay, look at for the IP version 6. So this is my IP version 6. If you need to break it down, so each is hexadecimal, right? I think that was about 6. So each hexadecimal digit represents 4 bits. So if you check 4 bits, making each group 16. So you have, just a second. So you have this. Now, this is actually shortened. This is not like the full format. Okay, let me just say, can you expand this to the full version of the IP address, right? So this is like the shortened format because there's what to call ANDing or approximating to different zeros, what's it called, leading zeros, because it's a way for us to like make it possible for us to write the IP address the way the IP address is this way, right? So this is not like the full version of the IP address. This is like the compressed version of the IP address. So let's see what the working looks like. Okay, so if you need to expand this, so this is what the full guy is going to be like. So 1, 2, 3, 4, 5, 6, 7, 8. Right? So this is 8. So you have so the IP address structure is hexadecimal, right? With 8 16 bits. So each of this one is 16 bits each, right? 16 bits, 16 bits, 16 bits, 16 bits, 16 bits. And let us check 16 times 8, rather 16 times 8. So we're going to have, I think, 128. So that's how we came about saying that IP version 6 is 128 bits, right? So I hope that's clear. So we say each of these is what? 16 bits. And how many sections do you have? You have 8 sections, right? So each of them 16 bits, 8 sections, and the maximum you can have is what? 132 bits, right? So this is the conversion of this into this. Okay, so I think in that differences, I think I've already addressed the reasons why we need IP version 6. So security is one reason, having to pass more information, having to have better support for mobile network. Imagine when we talk about mobile network now, you know, IoT device, small phones, large phones, portability. We won't be able to do that when we are running what's it called, IP version 4. Though we can do that, we'll be limited to how much IP address we're able to send out. Same thing for the total address space that we have possible, right? So these are some of the advantages, some of the differences that you have, or if you want to compare IP version 4 and IP version 6. Then another thing here is configuration. So you can actually configure IP version 6 manually for DHCP, But in IP version 6, auto configuration with stateless address auto configuration on the IP version 6 happens. You know, if you have a router, you have a switch, you have a layer 3 device, what you want to do is to decide whether you want to do static or whether you want to do DHCP. But in IP version 6, that happens automatically. Okay, so I think you've seen some of the reasons why you have IP version 6. I've talked about the benefits also. Okay, these are some of the things I just talked about. So you have 16, 16, 16, 16, then 16, 16, 16, 16. So all of that gives us 128. So each of them, right? Each of the address is about 8 bits. So in the shortened expression, so we're just trying to say, how do we shorten it? Because at times an IP version 6 typically is going to be very long. So there are different ways you can shorten it. So like, look at this one now, or let me use the example that I brought up for my PC. Look at this one, the way it is now. If you see this IP address, look at it. You see the way it is, you see that you can also do something like this on your system. Once you're connected to a network, just do ipconfig/all. You're going to grab your IP version 6 address, try and get to ChatGPT and try to generate what the full version is and how it can be reduced. Okay, so 2 methods. Just a second. Okay, if I have this IP address, what are the 2 methods to compress it, show work it, right? So leading zeros, if you have multiple zeros, you can remove those leading zeros. Then you can use double colon to like replace those consecutive zeros, right? So that way you're going to shorten the IP version 6 address, and you cannot be a little bit smaller, very mobile for you to move around or write. So you're not going to see IP version 6 address always very long like that. So most of the times it's going to be shortened. So if we have an IP version 6 address like this, 2 ways is to remove leading zeros in each 16-bit group. So if you have any zeros in front, you can take that off, right? So it's allowed. So it's a way for you to compress it. Then you can use double colon notation to replace any consecutive sections of zeros. So if you have a section that is just 0, 0, 0, you can just replace that with 2, what's it called? Double dot, right? Okay, so let's apply it. So this is our original expanded address. So if we want to use the very first method to remove leading zero, so if we have this, it stays at this. If we have this, it will remain 0. If we have this, it becomes 0. If we have this, it becomes 0. If we have this, all of this stays the same. So if we remove all the leading zeros now, we're going to get this, right? Then we can now use double colon notation. That's the second. So you can write your IP address as this. Or you can now employ the second method where you're not going to say, okay, I don't want to be having zeros. It's just like if you do programming or you do graphics, you're going to find out that we have what we call RGB values. RGB values, for instance, instead of saying it's hexadecimal, instead of saying hash 00, so instead of saying something like let's say hash 0000000, right? So this is 60, 1, 2, 3, 4, 5, 6. So this is hexadecimal, right? So instead of saying this, we just say what? Hash 000. So this is black. So if instead of saying slash hash FF, right? We just say what? Hash FFF. This is white. You know, this is RGB. The first 2 is red, second 2 green, then the third one blue, right? So any color that is this. So this is a way to like compress the colors. If you put this, you still get black. If you put this, you still get white. Okay, this is by the way. So for this particular one, you cannot replace all of this with just a double colon, and another day you're going to have this, or you're going to have this. So this is just a way to like replace or compress For the students taking this course for exam preparation, I'm going to share this chart on the training group so that it can help you understand this concept, and you can also try yours as well. So now we talked about different addresses, IP version 4, IP version 6. Mention these concepts. Let me see if there's anything that is important we can address. Okay, so this is also what we call our loop back address, right? So anytime you see .1, so this is still the same equivalent as the loop back address of 127.0.0.1 in IP version 4. Take note of this. This is very fundamental. You should be aware of. So how IP version 6 works in an inter-network. So it's time to explore the finer points of IP version 6. A great way to start is showing you how to address a host and what gives you the ability to find other hosts or resources on the network. And that's the job of DHCP, right? So the first one you have is manual address assignment, right? So if you're on the Cisco switch, you could do IP version 6 unicast routing. You can also do this IP version 6 address. You can assign an address to it. Then anytime you run through your commands and you say IP version 6 enable, you're just trying to make sure that all of the commands you've typed have actually been enabled or actually been implemented. Okay, so you have another concept of stateless auto-configuration. So auto-configuration is especially useful solution because it allows devices on the network to address themselves with a linked local unicast address as well as with the global unicast address. Like I said, most of the times for devices to connect, there are multiple address systems that needs to be employed. So I talked about the port number. I talked about the MAC address, which is 48-bit. I talked about the IP address. And if it's a IP version 6 configuration, instead of the IP version 6, version 4, they're going to be using an IP version 6. Okay, for example, let's say I have a device with a MAC address that looks like this. After it's been padded is going to mean that your entire address is going to constitute, or your entire block of addressing system is going to constitute your name, your different addresses, your MAC address, your IP address, and any identifier, your port numbers that's going to be used for communication. Okay, so neighbor discovery. So neighbor discovery is a very important point when we try to look at different routers you have on a network or different switches you have on a network. So when we say neighbor, we're trying to talk about a router that wants to know the other router on the network or the other router on top of its order in trying to communicate to the next router or maybe to the outside world. So there must be a way for these guys to like identify or know or find those addresses they have on their local link. So ARP does that function. So that's what the address resolution protocol does for us. So address resolution protocol helps us to like resolve. That's why at times you see on your PC, if you are connected to a switch, you're connected to a network, and maybe you don't come back after some time. By the time you return, you might have issues with trying to connect. What's actually happening is that there's an issue with the ARP table. The ARP table might be corrupted, or somebody else have been assigned those IP address, or the switch you are connected to have lost signal or have been reconfigured. So the ARP tries to do all of those resolving, right? In conjunction with DHCP, a new IP address can be assigned to that particular device or assigned to your device. That's why at times if you have issues, if you disconnect and reconnect, that can be resolved. Or at times if you go off the network and you come back to the network, that can be resolved. So the guy that does that is the address resolution protocol. So neighbor discovery enables things like telling which MAC address of the different neighbors. Neighbors here we mean PCs, devices, routers, switches, and the rest. Router solicitation, trying to say, okay, please, I want to communicate. So routers don't communicate with each other without first soliciting. And they have to most times constantly advertise. It's just like when a lady wants to woo, or a guy wants to woo a lady. So, ladies will always keep advertising. Even animals, like the peacock and whatever, they'll keep advertising. I'm here, I'm here, I'm here, I'm here, I'm here, right? You can speak to me. I'm here, I'm here. So that's what the routers do. They will always say, okay, please, I'm here, I'm available for communication. So they keep sending those packets. That's advertisement, right? So you always have router solicitation, router advertisement, neighbor solicitation, neighbor advertisement. Then duplicate address detection. So if you have been assigned an IP address, like I said earlier on, that is this last one here. If you have been assigned an IP address already and you go off the network, maybe you traveled, somebody else comes in and is trying to access the IP address, and the ARP protocol scans its ARP table and sees that IP address have not been used for some time. That's why, let me expand this a little bit and change that to, let's say, 28. That's why you're going to see that this particular IP address and configurations I have, don't forget we're doing IP config. You're going to find out that it has a lease obtained date and time, and it has a lease expired date and time. So this is just roughly around 1622, roughly around 5, 6, 7 hours thereabout, if my math is correct. Now, the thing is that if I'm still on the network, it might not lease out this particular IP address, this IP address that's assigned to me. And don't be surprised if I come after a few days trying to connect to this particular network, I might be getting a different IP address. That is this one, sorry. This one. So this is my preferred IP address. So this is what is preferred for me. This is what is preferred, it has assigned to me, right? So if I go off and somebody else has been assigned this particular IP address, if I comes back in my ARP table, I already have this as my preferred. If I try to connect, it will say something like duplicate IP address. So let me show you how it's going to look like. Duplicate IP address notification on a network, right? So you're going to see something like this. This doesn't used to be so common again. It used to be common in the days of Windows or Windows, let's say XP, maybe Windows 10. I've not so much experienced it. Maybe somebody can let us know in the comment section. So this is what it looks like. You just see a pop-up on your system and say Windows has detected an IP address conflict. So what's happening? The ARP, we have to try to resolve this. And a simple way to help the ARP is to server is, or the DHCP server is to do what? Get off the network, come back, and it's going to be resolved. You're going to be assigned an IP address. Or when you try to reconnect, it's going to look for any best available IP address and assign to you. Okay, so that's the summary. We've considered some very important aspects. We talked about NATs, paths. We also looked at neighbors. For your exams, you want to remember the 3 methods of NAT. You want to understand what is NAT, both static and dynamic. You want to understand what is overloading. You want to understand why we need IP version 6 address for exam. You want to understand link local, unique global. I think I opened TCP view for you to see those things. Then understand IP address, IP version 6 addressing. You want to know that IP version 4 is 32 bits, MAC address is 48 bit, IP version 6 is what? 128 bits. And you need to explain and know why. Okay, thank you very much. See you in the next module. And later on, we're going to run series that will have to address exam questions, how to answer them. I think I've done 2 on the channel, so you can check them. And if you have questions, you can just ask in the comment sections.